Hi everyone. So today we're going to solve code problem number 15, threesome. So in this problem, we have to basically find out the triplets which sums up to 0. And the condition is I should not be equals to j, I should not be equals to k, and j should not be equals to k. Basically, we cannot use the same element in the triplet. Okay, at the element at the same index in the triplet. So this is nothing but a simple extension to the two pointer or two sum problem in which what we'll be doing is we will be basically fixing one of our pointer and we will be moving the two pointers in the rest of the array. For example, let's say we start with the zeroth index. I'll fix a pointer at the zero index and I'll keep a left pointer on the first index and the right pointer on my last element. Okay. And we will simply exactly what we do with a two-sum approach. We will be just summing all these things up, and we'll see if this ends up to 0. If yes, we're gonna add that into our resultant array. So this is it. It's a comparatively easy problem, I would say. So let's head towards the solution. Okay. So first what I want to do is I want to simply just um, sort the arrays, sort the given array. Because the two pointer sum approach or two sum approach works best with the sorted arrays, because then you can take a decisive call if you want to move your left pointer or your right pointer. Next, I want to create my resultant array in which I'll be adding all my triplets. Okay. And one more thing I would like to have is number of elements in the num, so that I don't have to make this calculation again and again, right? So this is it. Now, what we have to do is I will be just I'll run a loop from index 0 to n minus 2. So we are keeping it n minus 2 because we want our two pointers at the end as well, right? So just to don't so that we just don't overflow or extend beyond our number of elements in the array. That's why we'll be having a loop from 0 to n minus 2. Okay. So for index in range, length of nums we already have, number of elements minus 2. Okay. Now, we have fixed, we will treat this index as our pivot element or as a fixed index. Okay. So our first element is nums of index. Okay. Now what we have to do is, as mentioned, what I'll be doing is I'll be initializing my left pointer as index plus 1. Okay, so left is index plus 1 and right pointer will be the number of the last element, or we can say number of elements minus 1, because in the number of elements we have, for example, 10, but our index starts with a 0, right? So that's why we're using this minus 1 over here. Okay, so we have our first element with us. So what we are looking at is remaining sum. We basically will have to find two elements such that it sums up to the remaining sum. Okay, so what I'll be doing is 0 minus first plus first element, sorry. Okay, this part is done. Now, a simple two pointer approach, while left is less than right, we are not having an equal operator over here because we don't want to use the same element in the triplet, or the same index element in the triplet, I would say. Okay, now it's very simple. Just check the condition. If nums of left plus nums of right is equals to remaining sum, then we will check. There was one more condition in the question that set must not contain duplicate triplets. So what we'll do is we'll check if list of List of first element, comma, nums of left, comma, nums of right. Basically, if this triplet is not in our resultant triplet, then only we will be adding this triplet. We will be adding this triplet into it, and I will simply just move my left pointer 1 point. Also, we have already sorted the list, right? So we can basically skip all the similar elements. So to do that, what I'll be doing is, as we have already incremented our left pointer, now while nums of left minus 1 is equals to nums of left. Basically, if my previous element was also same as my current element at the left index, and we are into our constraint as the left is greater than right, I'll be incrementing my left pointer. Okay. Next condition is elif my nums of left plus right is less than remaining sum. In this case, as we have already mentioned that we have a sorted array, we'll have to increment our left pointer, because obviously like all the greater elements will be on the right side of the current index. Else, simple, right plus equals to 1. This is it. And at the last, I will simply just return my resultant triplet. Okay, let's see if if I'm able to successfully pass the test cases. Okay, list index out of range. Fine, fine, fine. If nums of this is equals to remaining sum, and we have initialized it with number of elements minus 1. Uh, looks fine, looks fine. Okay, let's see. Or let me just pull it once and let's see. Okay, list index out of range. And this is happening for this particular line. We are moving -2. That is fine, I think. That is once reaches the result. See, oh, we are missing something for sure. Left is index plus 1, right is numbers minus 1, and it's fine. We're checking the condition over here as well. Oh, sorry. Yeah. So this in the right side, we should definitely, just use the negative, like the minus. We should use the negative operator, right? So this was the issue. Let's see. Yeah. So the test cases got passed successfully. Let's submit for further evaluation. Okay. So the submission got accepted successfully, and it didn't, got really good results. Not sure why. Last time I think, yeah, it was around the same. So we can try to have something optimized, and I'll definitely post the video if I'll get something on it. And thanks again, guys, for watching the video, and stay tuned for the upcoming one. Thank you.